Hello friends, this video on visualizing shapes part 2 is brought to you by examfear.com. No more fear from exam. In fact, there is another interesting fact that the three-dimensional shapes can be visualized as many two-dimensional shapes. That is, many two-dimensional shapes put together make a three-dimensional shape. You might find it hard to believe, but if you look at the example of the playing card that I had taken some time back, what did I say? One playing card is two-dimensional, but when you build a tower with many playing cards, that becomes a three-dimensional shape. So let's analyze some of the 3D shapes very quickly. Let's observe a cuboid. Okay, so what is this which you see on the screen? This is a square. So square is definitely a two-dimensional shape because it only involves two parameters, length and breadth. Now the speciality of square is that the measurement of length and breadth are equal. Now let's see what happens if we keep stacking squares one above another, just like this. So what do you think would happen? So this, when you are stacking so many squares one after another, you are actually creating the third dimension, which is the height. So you see, when you stack so many squares, so this actually created the third dimension, which is the height. So what is this? This is no more a two-dimensional shape. This is a three-dimensional shape because now you have, this is one side, this is another side, and this is the third side. So now you have three dimensions. So therefore this is a cuboid. So what happened? How did we get this cuboid? By stacking squares. So basically many two-dimensional squares gave rise to a three-dimensional solid cuboid. Let's look at a cuboid again. Now instead of squares, even if you take rectangles, these are also two-dimensional shapes, just that here the length and breadth are of different measurements. This is length and this is breadth. So if you stack many such rectangles together, then also you get a cuboid. So you have the length, you have the breadth, but now you also have the height or the depth, whatever you call it. And this height happened because of stacking so many rectangles one above another. In fact, you can also create a hollow cuboid from two-dimensional rectangles, somewhat like this. So when you look at a hollow cuboid, that means the cuboid is empty from inside. It is like an empty box. So the box is in the shape of a cuboid. Inside you have nothing. So here also if you see, these are, each face of the cuboid is a two-dimensional rectangle. So basically how many rectangles do you need to make a cuboid? You need 6 rectangles. One in front, one in back, 2 on the sides, one on top, one on bottom. So altogether you need 6 rectangles to form a hollow cuboid. Even a cylinder. Cylinder is again a three-dimensional shape. Think of any glass or a bottle. That's three-dimensional. You cannot make them lie down along the sheet of paper. Okay. But how do we get cylinder? We can get cylinder from circles. So circles are two-dimensional, as we know. Now if you keep stacking circles one above another, in fact you can try this out with coins. Maybe you can take 1 rupee coin and start placing them one above another. So by the time you have placed some 10-20 coins, what have you obtained? You have actually obtained a solid cylinder. Because by stacking the coins, you have created the third dimension, which is the height. And that's how cylinder is a three-dimensional shape. A sphere again is formed of many circles. So this is a circle which is two-dimensional. But when you have many such circles stacked together in a circular fashion, what do you get? You get a sphere. Like in the previous examples, whether you talk about the cuboid or the cylinder, we were stacking the two-dimensional shapes in a linear fashion. That is one above another. But in this case, the circles, if you stack the circles in linear fashion, that is one above another, you get a cylinder. But if you stack circles in a circular fashion like this, then you get a sphere. So when you look at a sphere, it is definitely three-dimensional, but it is made up of many circles. In fact, with this picture of the sphere, it gives you an idea that a sphere is nothing but many circles which have been put in a circular fashion. in such a way that, the radius of the circles keep increasing towards the center. Like here, the circle is smaller. As you reach towards the center, the circle is bigger. Again, when you reach towards the other end, the circle is smaller. Now, not by stacking these type of circles of different sizes, but same circles, if you stack in circular fashion, like how it is shown in this diagram, so you would get a sphere. The same is true for a cone as well. So if you take a right angle triangle and stack them in circular fashion like this, so what do you get? You get nothing but a cone. So by stacking these triangles, what happens? Now, triangles already had the height. So height was already present. But by stacking them like this, you create the circular base of a cone. Because when you look at a cone, so cone has a circular base, right? So in fact, you can try this out like this. Take a rod, take a sheet of paper, cut it in the shape of a right angle triangle. On one end, fix it to a rod like this, and then rotate it. So when you rotate it very fast, I'm not saying that the other end of paper will come and automatically join, but when you rotate it very fast, you see it as a cone. So which tells you that a cone can be made by rotating a right angle triangle about one of its short sides. So that's a cone. So with all these examples, we got an idea that any three-dimensional shape that we talk about, whether it's a cone or a cylinder or a sphere, all of them are actually made up of multiple units of two-dimensional shapes. Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.